For this particular problem, it would be nice to eliminate our fractions. Our common denominator is 8, so let's multiply the entire equation by 8. 8 times 1/2 t squared is 4t squared. 8 times 1/8 is 1. And 8 times 3/4 t is 6t. Now I notice that I have a t squared, so I need to get 0 on one side, and then we can solve by whatever method we choose. So let's subtract 1 from both sides and 6t from both sides. That will give us 4t squared minus 6t minus 1 equals 0. Now how about if we try the quadratic formula? A is the coefficient in front of t squared, which is 4. B is the coefficient in front of t, which is -6, and c is our constant, which is -1. Remember, the quadratic formula in this case will be t equals -b plus or minus square root of b squared minus 4ac all over 2a. Let's replace our variables in this formula with these values here. That will give us t equals the opposite of our b, which is -6, plus or minus the square root of -6 squared minus 4 times our a, which is 4, our c, which is -1, all over 2 times our a, which is 4. We'll start by simplifying underneath the square root, and -6 squared is 36. And -4 times 4 is -16 times -1 is a +16. In front here, the opposite of our -6 is 6, and in the denominator, 2 times 4 is 8. And that's what our t is going to equal. Now if we combine our 36 and our 16, we come up with 52, and we need to simplify our square root of 52. And factors of 52 would be 4 and 13, because 4 times 13 is 52, and 4 is a perfect square. We can use square root of 4 to get a 2, and 13 we can't do a square root of, so we'll leave it under the square root. You can simplify that off to the side if you need more steps. And then finally, I notice that I can factor 2 out of my numerator. So if I do that, I get 2 times 3 plus or minus square root of 13 all over 4, or 8. And when we cancel the 2 into the 8, we get a 4. So simplified, we get 3 plus or minus square root of 13 all over 4. That makes our solution set 3 minus square root of 13 over 4, or 3 plus square root of 13 all over 4.